Oh, good day, grades. My name is Miss Kelly, and welcome to this virtual mathematics classroom. Today, we are doing a brief recap on the number system. Then we are moving into uncharted territory. We are doing HCF and LCM. Grades, please you take down everything we covered today. Highlight it, underline, do whatever makes you happy as long as you take these notes down. Before we begin, I would like to inform you that you do have a pre-lesson quiz to do on quizzes. I will give you a brief outline of what it looks like. You can look on the screen, it looks like that. It asks that you please complete the Venn diagram. On that Venn diagram, we cover all the numbers, from real numbers, irrational, natural, and whole numbers. You have 5 minutes to complete this quiz. Go, go, go! Okay, whilst you are doing your quiz, we can move on. Please refer to page 1 of this textbook. Let's get a move on. I will show you what it looks like now. In your textbook, it asks you for a few definitions, or it gives you a few definitions, and here are the two that stood out the most for me. What is a natural number? Firstly, when you refer to your Venn diagram, natural number will be indicated to you with a letter N. Natural numbers are what we call counting numbers, and we always start at 1. Then we move on to whole numbers. These are numbers together with 0. We start at 0 and count, and we can count and represent all of these numbers from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Please take this down. I will take it down if you take it down. Let's go. Natural numbers. Please write it with an N. Make it a bold N. Then follow through with rational with a Q, irrational with a Q and the little hat on it, and so forth. Now, grade 8, let's take a look. We need to do some definitions. You will find these on page 5 of your textbook. It is 5 simple questions. 3 of them you will find on page 5. The other 2 you need me for. What is a factor? Well, factors of a natural number are any natural numbers which divide into the number without any remainder. Please write this down. Factors of a natural number are any natural numbers which divide into the number without any remainder. Then we move on to what is a composite number. These are numbers with 2 or more, 2 or more factors. These are called composite numbers. Numbers with 2 or more factors. Now, what is a prime number? Does anybody know? Yes, you know. Good job. It is what? I'm sure you can tell me. Tell me. Prime numbers are numbers that can be divided by themselves and by 1. Your textbook says numbers which have only 2 factors that are different from each other, namely 1 and the number itself. Then let's move on to HCF and LCM. This work starts on page 9. HCF stands for highest common factor. Highest common factor. Please leave a few lines as we will be doing an HCF sum. I will indicate to you when we need to go back to this section. Then LCM stands for lowest common multiple. Lowest common multiple. Now, grade 8s, before we get into the work, I have given you a worksheet that says spot the similarities. Spot the similarities. It's a thinking phase. Let's look at worksheet. Question 1 says, what can we divide both numbers by? What can we divide both numbers by? So let's go look. The numbers are 120 and 300 respectively. What can we divide both numbers by? I would say 60. Both numbers can be divided by 60. This is question 1. Please take this down. Now, let's look at question 2. Question 2 asks, what can we divide? What can we divide into 120 and 300 equally? What can we divide 120 and 360 by equally? Let's go take a look. Let's go take a look. I think we should start with a counting number. A counting number. Let's do a counting number. We are using the counting number. We start at 1 and logic dictates to us. We count 1, 2, 3, 4, 5, 6. Here's the thing. Can 7 go into 120 equally? Let's take a look. Take out your calculators, please. 120 divided by 7. Unfortunately not. It has a remainder. Let's try 8. Okay, it can do 8. Let's try 9. Definitely not. We can do 10. We carry on writing our numbers. 10, 12, 15, 20, 30, and lastly, 60. 60. Let's copy this down, grade 8. Okay, have you got it? Let's do question 3. Do the numbers have any prime factors? Do you know? If you don't know what a prime factor is, refer back to the definitions you took down, or ideally start this video from the beginning and take it all in again. The prime factors of 120 and 300 are 2, 3, and 5. 2, 3, and 5. 2, 3, and 5. Now, grade 8, we need to revert back our work. This worksheet is just to help you and to test your knowledge. We are now going to refer to an LCM and HCF portion of our work. I would like you to pause this video if at any time you are stuck or in need of help. Now, let's take a look. We are going to do page 9. We're going to do 3 worked examples. The first one asks us to write 12 as a product of its prime. Let's go do that. Let's write 12 as a product of its prime. We do number 1. The question wants us to work out 12. So we write 12 down. We equal signs 12. Now let's think. What can go into 12 equally without a remainder? I think 2 can go in. And 2 times 2 is 4. 2 times 2 is 4. And then we need to get to 12. What can we multiply this 4 by to get 12? We multiply it by 3. If you would like to check yourself, take your calculator. 2 times 2 times 3 gives me 12. Good one, grade 8. I hope you all got that. That was relatively easy. Now, let's do number 2. Number 2 says, write 15 as the product of its prime. I will give you a few seconds to do this whilst I read a book. Your maths textbook is so interesting. The answer is 5 multiplied by 3. There we go. Now, grade 8, let's do number 3. Number 3 gets a bit tricky, but that's okay. We are going to use a cheat. It's called the ladder method. The ladder method. Let's take a look. I would like you to please draw a ladder, as simple as ever. A ladder. We are going to start with 360. The sum reads, write 360 as a product of its prime factors. And we do this by successive division of the number by prime numbers. Remember, a prime number has no remainder. It can be divided by the number and by 1 itself. Right? What number can go into 360 degrees without a remainder? Without a remainder. 2. And if we divide 360 by 2, we get 180. Again, we are going to use number 2. 2 goes into 180 90 times. And that leaves us with 90. Can 2 go into 90 without a remainder? Take your calculators and check. Yes, you do. You get 45. Can 2 go into 45 without a remainder? If you say yes, please check. 45 divided by 2 is 22.5. That is not correct. Let's take a look. 3 can go into 45 without a remainder, and it gives us 15. Again, 3 can go into 15. How many times? 5 times. 5 times. And lastly, since we are working with prime numbers, the last one would be 1. The last number is 1. Now, grade 8s, your work is not done here. I need you to write this into exponential notation. And this is replicated or repeated multiplication of the same factor. And I would like you to remember exponential notation is a squished or a condensed version of writing out the factors. And the factors go as follows. 360 equals, dum, 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 2 multiplied by 2 multiplied by 2, now multiplied by 3, multiplied by another 3, multiplied by 5. Grade 8s, to make this even easier for you, I will put the answer over here. 2 multiplied by 2 multiplied by 2, 3 by 3 by 5. Here is the answer. Here is the answer. Please copy this down and leave one line open for something I'm going to show you next. I will give you 20 seconds to copy this down. Let's go. Let's go. Let's go. Time's almost up. Time is almost. Oh, goodness me, it's gone. What am I going to do? Your sum was 2 times 2 times 2 times 3, 3 times 5. In a simpler form, we can put it like this. 2 dot 2. No, I'm kidding, grade 8s. I'm so kidding with you. We need to do it like this. 2 to the power of 3. Because we have 3 number 2s. Multiplied by 3 to the power of 2. Because we have 2 number 3s. And then multiplied by 5. It's as simple as that. Please copy this down. Please copy this down. Now, grade 8, I'm sure you are nearly done copying this down. Let's take a look at the following. We need to look at the LCM explanation. Let me just read the textbook whilst you finish. Oh, it's such a lovely book to read. I'm sure you will enjoy it one day too. Grade 8, let's take a look at LCM explanation. And an LCM explanation. The LCM explanation. Ready? Let's go. Let's go. I would like you to please focus on the following numbers. I would like you to determine the LCM, which stands for the lowest common multiple of two numbers. Please write lowest common multiple here. Thank you. The LCM I want you to find today is between 2 and 4 respectively. Let's focus on 2. With 2, we write down the multiples of 2, or we add 2 each time. And it goes as follows. It goes 2, 4, 6, 8, 10. We can even go all the way up to 12. And now let's do number 4. Let's do 4. 2 equals this one, and 4 equals, let me hear you count, 4, 8, 12, 16, 20, 24. 4, and then we end at 24. Now, grade 8, I wonder, what is common? What is common? 4 is the lowest common multiple. Please highlight, circle, or underline your lowest common multiple. I will give you a minute to complete this if you are stuck. Now let's consider the following. When we write the LCM, I want you to lay it out as clear as possible. The LCM will be covering the same sum again of 2 and 4. Would like you to put it in a little table and head it as 2 and 4. And write down all the multiples you possibly can in one line before you run out of space. Okay, I hope you can see that. That's it. That is a 2. It's not a 1. That is a 2. Let's do this. The side of 4 goes 4, 8, 12, 16, 20, and 24. Good job, grade 8. Thank you. Now let's circle, underline, highlight, whichever floats your boat, the most common one. It is 4. We then put that fancy therefore sign. The LCM is 4. The LCM is 4. LCM is 4. LCM is 4. Please copy this down. Please copy this down. Now we are moving on to the highest common factor explanation. Highest common factor explanation. Please write HCF down. HCF. Let's take a look. HCF stands for highest common factor. Highest common factor. Please write definition down over here. Highest common factor. Now, when working with the HCF, I need you to write down all the numbers you possibly can that can divide into the number you are tasked to find, and make sure there are no remainders. If you do, for interest sake, 10 divided by 3, you get a remainder of 3,33333 or 3.33 recurring. That will not help you. It can be 0 decimals. It's very important that you take note. 1 and the number itself is a factor of that certain number. Now, I am tasking you to find the HCF of 135 and 145. Seems quite daunting, doesn't it? I have a 5-step plan for you. The first step, find the prime factors. I will write PF. I need you to please write it out in full. Prime factors of 135. These are, what are they? Does anybody know? I know. It's 3 and 5. If you are stuck with what a prime factor is, please rewind the video and find yourselves in the definition section, or refer to page 5 in your textbook. Got it? Prime factor is a number that can be divided without any remainders. And if we do 135 divided by 3, we get 45. No remainders. If we do 135 divided by 5, we get 27. Also, no remainders. Step 2 is the same, except it is the prime factors of 145. And let's find those out. Let's find those out. I have another cheat for you. If you have a Casio calculator, please input the following. Switch your calculator on. Type in 145, press the equals button. Then find the shift button, which is next to alpha, the shift. Then press fact. It is the 3 dots in a circle. Shift, fact. And the prime factors of 145 are 5 and 29. 5 and 29. 5 and 29. Let's copy this down. Now, grades, to move on, we are going to the third step of success. I need you to list all the positive integers or numbers that divide into 135 without a decimal or a remainder. And those would be 1, so 1 and 135 can go in. 3, 5, 9, 9. What else? 15, yes, you are correct. Any more? Yes, 27, and 45. Here we go. Those are the factors of 135. Now the same step, we repeat it. The factors of 145. Again, I cannot stress this enough. No remainders, no decimals. Let's do this. We get 1, we get 5, and we get 29. Out of interest's sake, let's do some calculations and see. 145 divided by 30. Nope, unfortunately not. Does not work. 145 divided by, let's say, 15. Sorry, pal, does not work. Those are your prime factors. And then number 5, it's a secret step. You do not need to write the number. I just need you to highlight, underline, or circle the highest common factor that both these sets of numbers have. If you would like to, you can put in step 5 for your own sake and say the HCF is 5. HCF is 5. Please copy this down. 5 is the common number in this set of numbers. 5 is the common number in this set of numbers. 5 is the common one.